I'd like to walk you through the healthcare project, both the operations you would perform on your calculator, ideas you would need to be able to do with Excel to take a chart and put that into a Word document, and then just overall the ideas that I would like you to gather by the end of this project. I'm using Zoom for this so I can go along a lot of different programs. So what I want to do here to start out with is share my screen and start getting to, in particular, an emulator for the graphing calculator that we use in class. One nice thing about this is it's going to have all the different screens. Our calculator only sees one at once, but that's fine. We can work with that. And let me also bring up here for a moment the actual project itself. So if you give me just a second there, got a lot of documents going here, so make sure you get the right one. And healthcare project, the practice problem is what I would like to discuss with you. So let me bring it on over here. And excuse me. To really bring out here at the beginning that what our goal is to take some data about healthcare cost per person over a number of years and create a model for that. That's definitely something that is of concern. How are healthcare costs trending? How are they going to be rising or falling? How can we plan for those? So what I've got here, this is data from the government, I do believe, from the years of 1986 to 2008. And if you look at the values here, those are values that we can enter into our stat editor on our calculator. Sometimes I like to ask students to count so many years from a first year. So if I was getting ready to enter some values in the calculator, I might say, well, I'm going to say 0 goes with 1974, and then 4 goes with 2,834. But I'm actually going to step back from that here. I'm going to step away and use the actual values because the technology is going to be able to really work better for us if we use 1986, 1990, the actual year. So I think you can see both of these here at once. Actually, no, I'm going to need to be able to see both. So I'm going to move the Word document over here to the side so I can see those. I got a couple screens going. And what I'm going to do here is get over to my calculator. And if you remember, if we want to enter in values for stats, we hit, we hit stat. We need to edit. And then they'll give us a couple lists. I've got some past data in here. You might as well. Let's see what we need. So I've got, if you look on the sheet, the practice problem sheet, we got 1986, 1990, 1997, 2003, and 2008 as important dates. If you should happen to have more data, you can delete that off. If you don't have enough, just type over it and add what you need in there. But the costs are not the same. We've got 1974 or $1,974. We've got $2,834, 4,174, 6,099, and 7,990. Those are the values that we have. Now, I always double check these because if you make a mistake now, it really throws everything else off. 2008, 7990, 2003, 6099, 1997, 4174, 1990, 2834. And again, I'm not counting so many years from 1986. I'm actually using the year itself, and that's what I need. I've got those values. So if I'm taking a look at what we've been asked to do, the very first thing is to plot the data using Excel, and we'll pull Excel up here in a minute. And just to explain why would I even want you to be doing this, Excel is a very handy program. Hopefully you take some sort of class at your while you're at USI that gives you some familiarity with it, because it's just very, very useful. It's like being able to create a Word document, being able to create a spreadsheet is another important thing to be able to do. So what I would do is open up Excel, and it's important to remember that you've got Office 365 as part of your USI account, and you can access the Office suite. And what I'm going to do here, I'm sorry, it's that whole issue of being on the screen I want at the time, is I'm going to type the data in Excel just like I did in my calculator. So 1986. And I gave it a couple headings, a year and cost per person. A lot of times when you're working in Excel, the headings for the column go into titles for that particular part of the chart or graph that we create. So it's worth your time to do that. So 1986, I'm going to take my years down vertically, 1990, 1997, 2003, 2008, and putting the cost in there as well. I'm going to add a little bit about Excel as we go through here as well. Perhaps you're familiar with it. I'm not an expert, but I always like to kind of come back from it from time to time and see what kind of new features I can learn. And since I was dealing with prices, I went ahead, if yours is like a general, I went ahead and took it as a currency. I didn't need to worry about any change on this, so I actually backed off on the decimal. So normally when you put currency, you'll have 2 decimal places, but you can move that decimal back to whole dollar values, and it just kind of cleans the data up a little bit. Now you're seeing something down here at the bottom right. I've been working with this a little bit beforehand. Let me show you here. If you're trying to create a chart with this, if you go, let's see here, get all my options here. We want to insert, and in particular, you got all these different charts, and sometimes it's overwhelming. If you look under scatter, so we're going to essentially create a scatter plot. I don't want it to connect those dots. I just want them to be on there. And that's kind of the first thing I would get if I was to just say, create a scatter plot. But I want to show you a few other things. You might take this further than I do. You might clean this up, make it look nicer. But I think there are a few things worth showing you as we go through here. And it's got a nice kind of horizontal range here, but I don't want it to go as far as it is. So if you right click on it, you can format that axis. And I don't want the minimum to be 1980. I think 1986 would be just fine. And 2011 is how far it takes it out. You could take it to 2010. I think I've done that in the past. You could take it as slow as 2008 if you wanted, just as long as we've got a sort of a snapshot of the data that we've included. Some other things here is I might want to have a little bit more as far as horizontal subdivisions, and it's going like every 5 years. I'd like to say go every 2 years. If I went every 1 year, it kind of gets a little busy. If I went every 3 years, sometimes it's a little hard to tell exactly horizontally. You should be able to adjust the miner here, so it does give you tick marks vertically between each of those, but for some reason I'm missing something right now and it's not showing those up. There are lots of different Excel tutorials that you can Google and watch online, so if you're interested in that, take a little bit further. I would also like to I've formatted the grid lines, formatted the axis. Let's see here. I'd like to change the title a little bit, show you how to do that. Let's see if that's showing up for me. Oh, here's one thing. My little zoom box is right over where I can change what I'm formatting. So a lot of times, let's see here. Is it going to let me do that for you? Not at this moment. So let's see here. Let's format the axis. We've done that. Major grid lines. I may just have to leave it alone for now. It's not a lot to tinker with, but I'm not an expert on the spot. I can figure things out as I need. There are some other things though I can bring up to you rather than just the formatting. So if you click on the points themselves and then right click, we can add trend lines to this. That's one nice thing about Excel. That kind of gets at sort of the heart of this project, is that if I was to try and create a model, what would be the best model I could come up with? Well, looking over here on the far right, you can create a linear model. That's what the trend line is. And you can kind of get an idea, well, does this function look to be linear? And remember, a hallmark of linear growth is sort of this fixed rate of change. Every time you have a certain run, you have the same amount of rise. That slope is constant. So if I went over 2 years, I would expect the same amount of change vertically every time. It doesn't look like the points fit that exactly. Not every single point is on this trend line. So maybe there's something better out there. Well, Excel has lots of options. And we're in a chapter now with polynomials, and what we can do is actually model it with a polynomial of order 2, degree 2, a quadratic, lots of different names for the same thing. And you kind of see how you get a little bit of curve to it now, and it's fitting a bit better. I could go to a cubic, and you see how it's starting to wiggle a little bit more, getting closer to all those, and I could even go to a quartic where, bam, it's going through every single point I put in the table. So, hey, we might be sold on it already being, hey, a quartic would be the best model because I can construct a model that matches every single data point. And that's something we're going to discuss as we go through here. But for now, what I want to do is actually take that trend line off, and I'm going to put into my Word document just the scatter plot all by itself. At the end of the project, if I can remember, we'll come back and we'll put the one that we find to be the best model, because today we're going to narrow it down to 4 things. Is a line, a quadratic, a cubic, or a quartic the best model for the data? So let me see here. If you want to get rid of something, hey, what can you do? Undo things? You should be able to right click on it as well and delete it off, delete the trend line, but sometimes it's just a little bit easier to undo what you've already done. So let's see here. I had messed around, kind of tinkered with a graph earlier. This one's matching up just fine. Hey, I said I would take off the trend line. Let me take off that. Well, let me click on it. It's being difficult now, isn't it? And hopefully I can just delete. Oh, this is a little embarrassing. I'll tell you what, I'll hold on to that for now. You start to put a camera on yourself, it always makes you do silly things. So what I'm going to do here is copy the table, and then I'll bring my Word document on over here, and let's paste this into the document. And sometimes it takes a little bit. Sometimes it takes up more room than you want. That's one thing I've always had a little bit of trouble with whenever I, as a teacher, am creating documents. Sometimes images that I insert in take too much time. So, uh-oh, lots of people coming in here. Are we good?
Our post person must have been trying really hard not to have to deliver them to the house because they were wedged in there pretty tight. Plastic bag for Mimi to use to get it out. Now she's going to put it in the trash bag.
Okay. I'm recording a lesson here, okay?
Okay.
Okay, I think we're back here. Had some family coming in, just needed to quiet it down a little bit. So if you have too large of a image when you insert it, you can go down here to picture, and if you click on size, this scale part, a lot of times I might have to take it down to say 60%, 50%. I think here it's actually a pretty good fit. I'm going to leave it alone at this point. It actually pasted in there really well. But if yours is too large, you would want to make sure, let's say I wanted to go down to 80% on both of these. Make sure you keep the percent signs on there as well, but that would shrink it for you. Make sure you change both of them, both the height and the width. If you needed to change that again, go back to picture, size, height and width, just adjust those to whatever you might need. And you can shrink it to the size, because what I want to do for this project in particular is make sure that this footnote down at the bottom, that the two-part C, is all on the front page. We don't want it to lose that. If I put a page break there, you kind of can guess that I'm doing my best to make sure that that's where the first page is. Okay, so there's a little bit of a tutorial about pasting some data into a Word document from Excel. So this first question afterwards, by observation, what type of model do you think it might fit it the best? This can really take on a lot of different responses. I'm looking for reasoning more than anything else here. We could say the data does not look linear due to the growth not being constant. It could be modeled with quadratic, cubic, or quartic function. Oh, what's tapping there? So that's kind of the first impression, that you don't have to be dead on. This is kind of what we thought. Remember, when we looked at it, it looked like the quartic might be the best one out of all. But that's kind of where we're at for now. The next part asks us to use our graphing calculator to come up with some models and to report the R-squared value, or the coefficient of determination for each of those. So it may have been a while since we've done that. Let me show you with the emulator what we can do to get those equations going on our calculator. So we've got the data in already. That's nothing we need to re-enter. But this time we're going to hit second stat. Oh, excuse me. Second stat. Oh, sorry. Just stat. Pardon me. And we're going to go over to calculations. And what we're going to do here is we're going to get several of these models built into our calculator. And linear regression is the first one I would like to do. So whenever I do that, it's going to ask me where I might want to store that equation. And then rather than having to write all that down, I'm going to hit alpha trace. And hopefully on your calculator, it comes up with these options of Y1 through Y4. I want Y1, and bam, it's there. If it didn't show up on yours, you could hit variables, VARS. You could go to YVARS on the top. You could go to function, that first option, and then you can pick which one you need. Okay? So let's see if I've lost everything I was at there a moment ago. It's worth showing you, but I want to make sure. Oh, while we're at it, if you do not have all that showing up, make sure as well when you work these, maybe there's an R-squared value that doesn't show up later, that the stat diagnostics, right now mine is not on. So if I was to work all this out, that R-squared value wouldn't show up. So I need to go over to on, highlight that, and it will work much better. If the stat wizard isn't on, you want that as well. If you have an older calculator and you cannot find that stat diagnostics this way, you can hit second, catalog, and you just gotta go. Oh, this might take a while. Bear with me. If it wasn't crucial, if I didn't have to do it, usually each semester I would stop. Almost there. Should be diagnostic on, diagnostic off. Could be stat. No, there it is. So you see it's trying to, I hit the down key one too many times. Patience with me. Sometimes this can be frustrating. Okay, it's moving back up now. Okay. Almost there. Okay, so if you are not seeing an R-squared value, if you click on diagnostic on through the catalog, that would work just like going to the stat wizard and turning that on, just so you're aware. So let me get back to where I was. So we were doing stat, calculate, linear equation, and we were going to save our equation. And since I can do this with alpha trace, I'll do that. And bam, there you go. It'll take a moment, but it'll update in this window here for the y1 that the equation of, let's see here, 267.89x minus 530,307. It'll show up in there. That model will be used for us. And there's one other thing while we're at it. You see this value of 9799? That's something that we will want to record. 0.9799. That's what we'll want to record as our R squared value. Please don't grab the coefficient of, the correlation coefficient of 9899 if you round it at 4 decimal places. That's for comparing lines to themselves, or that's for describing whether the linear regression is a good model. The R squared value is there to compare linear to quadratic to cubic to quartic. That's a little different. I don't want to confuse those. And we're going to go out 4 decimal places when we have these as well to kind of have a lot of comparison. We don't want to round too much. Okay. We need to do this 3 more times. Let's get to it. So we'll hit stat. We've got calc. This time we're going to go down to the quadratic, so number 5. And I want to store this as y2. You might notice that if it's a 2nd degree, I'm trying to save that in y2. If it's a 3rd degree, I'm trying to save that as a y3, just to kind of put that out there. Okay, and if we calculate this one, we're going to have as our coefficient of determination 0.9984. 0.9984, and I like to put these in red, these responses that I'm adding in there, and I'd appreciate it if you did the same on your project if you have a different color for your responses. And let's see here, if we keep going with stat, calc, cubic, and I'm going to save that as y3. Calculate that on up. This time our coefficient determination is 0.9991 when we round it, 0.9991. Hopefully you're also seeing why it's so important to go out 4 decimal places, because these values are really close to each other. Stat, calc, we're going to go down to option 7, the quartic regression. And let's save that as y4. Almost done with this stage of the project, or practice problem. And let's see here. Oh, wow, nice one. We've got a value of 1.0000. It could be thought of as, say, 100%. It's a perfect match. Okay, so that's what I'm wanting to do in this part, is to gather these coefficient of determination so that we can have a rather quantitative way of comparing the different models. This whole difference between qualitative and quantitative, we can have a feel for whether one thing is better than another, but it's nice to have a measure of why one thing is better than another. So looking through here, if you go on the next page, based on the R squared values, which appears to be the best fit, well, that's definitely the quartic. We noticed that earlier when we graphed it. It went through every single point. It really seemed to tick all the boxes. But we want to make sure that whenever we make a final conclusion, that we're not ignoring the context or the reality of the situation. So what I want to do here, let's scoot back over here to our graphing calculator, and let's turn on our stat plot. So second, y equals. The stat plot, I'm going to work on the first one. Right now it's turned off, so I'm going to hit enter and turn it on. The type, I don't want to connect the dots, so I want to scatter plot. It's doing everything else is probably going to be set up just fine. And then let's talk about window for a minute, because we're getting ready to graph these. if you, I'm sorry, I hit table set. If we go to our window, we didn't have any negative values. So let's think about what was our first time value? That was 1986. Let's just use that as well. Sort of like what we did with the Excel, and we'll go to 2010, and we'll count by, say, 2-year intervals. Now, when it comes to Y-min, Y-max, let's think about the money that was involved. I don't want to talk too much about negative values on the y-axis, but I want to have a little bit beneath my my axis so it doesn't seem so scrunched. And you also might notice here I switched from a minus, from a subtraction sign to a negative sign. If you type subtract 1,000, that's different than minus 1,000. If you're getting a sort of a error on your calculator, it doesn't want you to enter a certain thing, it needs to be negative 1,000, not subtract 1,000. And as far as y max, we saw something as high as 10,000, or sorry, 9,000 something. I'm going to put 10,000. That's my y max, and I'm going to count by 1,000 as I go through. That's good. And one last thing here, I want to adjust what's being graphed for now. So if you haven't noticed before, you can click on the equal sign when you enter your equation editor and turn on or off a graph. Okay, so just to get started here, let's see if the data looks good. And I can see I've got the data graph, so let's start to put some models on. I'm going to go back to the y equals, and I'm going to turn them all on. Go over, equal, turn it back on. You might be wondering, maybe you didn't want to do it exactly this way, that's fine. But the important thing is we'll make sure the data was graphed before I start to mess with any models. And then whenever I do this, pardon me for a second. When I do this, when I graph it, let's see how these look. It's a little linear, it's kind of like what we had with Excel. The quadratics looking a little better than linear. Seems like it's trying to reach those points. Cubic, hey, it's doing even better. And the quartic, I must not have turned it on. Sometimes that happens. And you know what, in the interest of predicting future events of these models, I'm going to change my window a little bit. Let's see what's, say, going on in 2000. Let's go far out as 2020. And graph it. The line always seems to be moving up. Farther in time, the more it's going to cost. The quadratic seems to be doing the same thing. Now watch this part. Watch the cubic. It's doing a real good job of passing through the points. That's good. For some reason that quartic is not graphing. It just doesn't want to graph, does it? I wonder why. There we go. For some reason it wasn't working for me. So I got the quartic, it's passing through those points. It's the one we thought was the best model out of them all. And then watch this. That's an issue. This quartic model was looking really good. But you notice how suddenly it begins to turn downward. That doesn't seem reasonable. And if I even change my window a bit more, say let's go out to 2050. You kind of wonder how long any model would work, but this one in particular, if I allowed it, you know what? I'm not going to graph them all. It may be stuck now. I'm not going to graph them all. I am just going to graph the quartic to really bring out a point. And the cubic's still going. Why is it being so difficult about that? Oh no, it's going, it's going. So this model for the quartic turns down to the point that eventually it looks like you're going to have a negative price prediction or a negative healthcare cost, and that isn't realistic. Another way of putting this is that the end behavior is not appropriate. If you looked at the y equals, maybe you noticed this whenever I was beginning, it had a negative in front of the x4th. If we have an even degree with a negative leading coefficient, it turns down on the edges. If we go back to our questionnaire here, is the function the quartic appropriate? No, it can't be here due to the end behavior. We cannot expect healthcare cost to become negative. So where we're at now is a situation where we need to look for an alternative. Is another function a better fit? Well, if you go back, if we sort of get rid of the quartic model, I'm going to strike through that for now. The next best correlation coefficient comes from the cubic. And just to make sure that we're not, once again, picking something that has a negative leading coefficient or something that's going to cause us to eventually predict negative healthcare prices, I'm going to graph it all by itself. So that's looking good. Might be wondering, well, you could adjust the window. Maybe there's something you're missing. Let's go back to the formula. And you'll notice that in front of that x cubed, we've got a positive, rather small, leading coefficient. So if you got an odd degree with a positive leading coefficient, it's going to turn up as you go to the far right of the graph. So that's okay. That now makes sense that the next best candidate for us is the next best model. The cubic has the next best R squared value. Let me adjust that a little bit. I like to have my superscript there. So is another function a better fit? The cubic, why would this be a better fit? Has the next best R squared value. There we go. It's easy to make your argument when you have tools to reinforce your conclusions. So we want to figure out when we predict healthcare costs to hit $9,500 per person each year. Well, our calculators are very good at solving equations if we should need them to. And what I'm going to do here is actually go to my Y1, my equation editor, and I'm going to go down to the last option of, oh, I'm sorry, I went too far. Underneath the last option to Y5 and put 9,500. Now, if you're curious why I'm doing this, what I'm going to do is to graph and see where two functions intersect. Our calculator has a good option for that. So if you hit second trace and option number 5 for intersect, you can let the calculator know that you would like to intersect the two curves, and it's usually going to want you to guess. And it says down here, we can think of this in terms of years. In about 2011 or 2010.996, that's not the 9th or 10th month, that's 0.9 of a whole we had to watch there. 0.99 years is pretty much 12 months. So what we got going on here, let's go back to our question. Using your chosen function, when would you predict your healthcare cost hits $9,500 per year? Well, you could report it to me there using the graphing calculator intersect command, intersect feature, healthcare cost would reach 9,500 around 2010, I do believe. Let's make sure I haven't remembered anything wrong. Oh, I'm sorry, 2011. I needed to round up a little bit. So around 2011. There you go. Really isn't a whole lot to show there. I wouldn't expect you to set your cubic equation equal to 9,500 to solve. Your techniques of factoring by grouping, you can't use a quadratic. Those techniques that we're familiar with just don't work. You have to use a numerical method here. What would each of your functions, I'm sorry. So that answers really part G of taking our model and figuring out when something happens. Part H, when would each of your functions predict the healthcare cost? What would each of your functions predict the healthcare cost to be in 2014? Let's use our graphing calculator again, because we've used the graphing calculator to intersect. We can also use it as a table. So if I hit second window, second table set, I can make sure that my calculator would allow me to enter values in. So if it doesn't have independent ask, you need to highlight that. And then you can go to second table and you can start to type in what you got. Now here's the thing. Earlier I turned off some other functions. So if I go back to Y1 and hit the equal sign, because I want to know what the other predictions happen to be. I'm not really too concerned about the 9,500, so I'm going to turn that off for now. I'm done with that. So I'm going to highlight all those equations and now go to the table, and it's going to give me the values to the nearest dime. Well, if you'll notice the directions in the problem, I asked you to let me know accuracy to the nearest cent. So we'll have to do a little bit difference here. Pardon me on this. So what we can do is actually on our calculator, we can hit on the home screen. So alpha trace. Now, however, you might have to hit the vars, y-vars function one. You might have to hit that. But you type Y1 and then type in 2014, it will use that format and calculate it for you. So we could say that $9,221.89, 9221.89, that's the cost we expect in 2014. And I will continue this with the other ones as well. So let me try that out. I could say alpha trace Y2 2014. And this time I've got, this is for my quadratic, 10,626.88. Don't forget the dollar sign. And I did want to make sure that the other one was in red. Okay. And I'm just going to repeat this at least one more time. I'm not too worried about the quartic. I just use it to illustrate a point. We've already kind of ruled that quartic out. But if I hit alpha trace Y3, Y4, have to watch about going too fast. So 2014. Alpha trace, third one, 2014. This one's 11,000. We'll have to bring this up a little bit. $11,254.33. Got that. And let's do the last one here with our Y4, alpha trace, fourth option, 2014. And we get $9,115.04. It's already kind of hinting that it doesn't fit with the others because it's so much lower. So there's an idea, of what these values would produce in 2014. Now why are we doing that? Because we've got one more thing we need to consider. See, when we began this problem, going back to our graph, we had this really nice quartic that passed through every point we had. The trouble was, when we looked at its end behavior, it wasn't turning the correct direction. So we said, if we're going to use a model, it really should be the cubic, because it's the next best as far as R squared. It looks to be matching with the right end behavior. But if you were to take a look at the actual healthcare costs, because you sometimes might look at extra data being added to your model, in 2014, actual cost was $9,523. Well, the cubic is $11,254. That's almost $2,000 off. That's a lot of money to me. Over a year, $2,000, I could do a fair amount with that. So in view of this, what would I say about the ability of my cubic to predict cost? I would say that cubic is projecting too high. Projecting too high of a cost, or growing too quick. I need to go back and pick something else. A lot of times this is just the way it is when you look at models. And so I'm going to go back and I'm going to mark out that cubic on my list and think, well, there's two left here. I go back to the linear and the quadratic. Out of those two, the quadratic's a little bit better of a coefficient of determination. And then whenever I look at the value, 10,626, that's not real close to the value. But 9,221, that's just a few hundred off. So if I start to think about three different things, the R squared value, the validity, and the effectiveness. So let's make sure we're clear what those mean. R squared value, the closer something is to 1, the better the model is. The validity, does the end behavior seem realistic? And effectiveness, if I actually give you some extra data, does a particular model do a better job than any other model? Well, based on all that I've got here, the quadratic, I would like to say that's my next best. But the trouble is, it's still projecting too high. So I would have to go with the linear function provides the best estimate and matches the correct or the expected end behavior. So I would recommend the linear model. I hope this has been helpful. I'm sorry if it took a while to go through it all, but nice thing is you can fast forward me, you can reverse and see if there's a keystroke that I missed that you wanted to see again. But what I wanted to do with this project is to guide you through what happens when you create a model. There's a lot that goes into it. It's more than just one number telling you whether a model is better than any other. There's a lot of things that you have to consider. If you have any other questions, send me an email. Thanks for your time.